So we have just learned how to solve quadratics by completing the square. And you saw that that's a little bit involved in terms of the number of steps that you have to do, and it's not always easy. So we really want to avoid solving by completing the square unless we absolutely have to. So what we want to do is kind of develop a way of assessing which solution method we should be using when we try and solve a quadratic function. So there are a couple of different methods that we've learned so far. We've learned how to solve by square roots. And so when we solve by square roots, we really can only do that if we can isolate our x squared term and have no other variables. So really we're going to use this method if we can write the equation as either x squared equals a number, or as some quantity squared equals a number. So if you can isolate that squared term, we're going to solve by square roots. We're going to solve by factoring if we can actually factor. So if it's not an x squared only term like we see up here, if we've got an x squared and an x, then we're going to go ahead and try to factor. If factoring doesn't work for us, then we're going to complete the square. So we're only really going to use this method if we cannot solve by square roots and we cannot solve by factoring. If you do happen to complete the square with something that did factor or with something that did solve by square roots, you are going to get the same answer in the end. So it's not like you'd be incorrect. It's just that you went a more difficult route in terms of solving. So we're going to look at a few examples, determine first which solution method we should use, and then we'll actually solve. So here is our first example. We have x minus 4 quantity squared minus 3 equals 1. So in this case, we can easily isolate our squared term, which means that we should solve by square roots. So we're going to isolate that x minus 4 quantity squared. I am going to add 3 to both sides. So I've got x minus 4 quantity squared equals 4. And now I can take the square root of both sides of my equation. So the left-hand side is x minus 4. And the square root of 4 is 2, but don't forget that it's positive or negative 2. Now when I get here, I am going to add 4 to both sides. But when I add 4 to plus or minus 2, that does not give me plus or minus 6. It doesn't give me plus or minus 2. I really want to split this into x minus 4 equals positive 2. And x minus 4 equals negative 2, because plus or minus 2 is really two different numbers. So here when I add 4, I get x equals 6. Here when I add 4, I get x equals 2. Okay, so we have another example here, and this probably should be an equals 0 so that we are solving. So in this case, we have an x squared and an x term. So that means that we're not going to be able to solve by square roots. So I'm going to try factoring. So if I can get factoring to work, then I don't have to worry about completing the square. So here, I'm going to try and break this down into two sets of parentheses. I know 2x squared has to come from 2x times x. That's my only set of options. I know that 7 has to come from 1 times 7. Again, my only set of options. I need my outside plus inside terms to give me this 13x. So if I put my 7 here and my 1 here, outside I have 14x, inside I have 1x. I need a negative 13x. That's going to come from a negative 14 and a positive 1. So to put my signs back in, negative 14 is 2x times negative 7. And then the 1x is 1 times x, so it's going to be a plus. So now that I have my factors, I set each factor equal to 0 and solve for x. So over here with 2x plus 1 equals 0, I subtract 1 and divide by 2 to get x equals negative 1/2. And here I'm going to add 7 to get x equals 7. Okay, now 7x squared equals 21. In this case, we have x squared only, so we're going to be able to isolate this x squared. And since we can isolate it in terms of no other variables, this is another solve by square roots example. So I'm going to go ahead and divide both sides by 7. It gives me x squared equals 3. take the square root of both sides. And then again, when I take that square root, I get the plus or minus. Square root of 3 doesn't simplify, so my answer is just plus or minus square root of 3. Okay, so here we have 7x squared plus 28x plus 35. And so here we could, because there's an x squared and an x, try to factor. So if I were to do that, I would need a 7x times x for the 7x squared, and then maybe a 7 times 5 for the 35. But if I put my 7 here and my 5 here, I'm going to have a 49x and then a 5. So there's no way for me to get a 28. If I try and flip them and put my 7 here and a 5 here, I'm going to get a 35 and a 7. So that will give me 28 if I subtract both, or if I subtract. But what's going to happen there is, what did I say, a 5 here and a 7. This outside would give me 35x. This inside gives me 7x. So if I do 35 minus 7, that will give me a positive 28x. But when I go to put my signs in, this would have to be a plus 5 to give me a positive 35 and a negative 7 to give me a minus 7x. So now when I do my last term times last term, that gives me a negative 35 and not a positive 35. So this one doesn't solve by factoring. So here we have to complete the square. And again, we're doing that because we cannot isolate just an x squared term with nothing else. And then we also cannot, we cannot factor. So I'm going to go ahead and get rid of this here so that I just have a little bit more space to complete the square. Okay, so when I go to complete the square, I need to write things as a 1x squared plus bx equals everything else. So here, I need to move that 35 over. So it's a negative 35. I need to divide everything here by 7. So it'll be an x squared plus 4x equals negative 5. Now that I'm in the right form, I can calculate b over 2 squared and add it to both sides. But again, we do b over 2 squared once it's written in this 1x squared plus bx equals everything else form. So we have to do it with a b value of 4. So I've got 4 over 2, which I need to square. So it's going to be a 2 squared or a 4. That 4 gets added to both sides of my equation. So this is going to be x squared plus 4x plus 4 equals negative 5 plus 4. And again, if you add these together all in one step and just write equals negative 1, that's fine. I like to show it so that we don't forget that we actually added it to both sides. So now on the left, we're going to write this as a binomial squared. This is going to be x plus 2 times x plus 2, or x plus 2 quantity squared. And now I can add these together to get negative 1. Now I'm going to solve by taking the square root of both sides. So I have x plus 2 on the left equals plus or minus. The square root of negative 1 is I. So that's going to be x plus 2 equals plus or minus I. And then I subtract 2 from both sides. Usually when we write our answer here, we write it in standard form. So the negative 2 would come first, plus or minus I. And I can leave my solution this way, or if I want to write it as it's two separate solutions, it would be a negative 2 plus I, a negative 2 minus I. So your assignment for tonight is going to be just to look at several different quadratics, figure out which method you would use to solve before solving them. So some problems in this set are going to solve by square roots, some are going to solve by factoring, and others are going to solve by completing the square.